All right, ladies and gentlemen, so today we're going to take a look at more modeling with our similar figures. These pictures are going to get a little bit more complicated. That's why we started off with the easy ones with the person and their shadow and so on. But what I have happening here is I have a person who's standing up, and I have I have a building over here, right? So here's my person, A to B, here's my building, and what's happening is they put a mirror here, and you'll see that what we're doing is we're looking down at the mirror and then looking up to see the top of the building. And we know this angle, right? These angles are both 36. So I want to know, explain why triangle ABO is similar to STO. Well, it's similar because when you're standing straight up and down and the building's standing straight up and down, you have made right angles. So right now I have 36 matches and I have the 90s that match. So it's similar because there are two pairs of congruent angles. All right, well, now label the diagram with the following information. The distance from eye level straight down to the ground is 5.3 feet. So eye level straight down. So this side is 5.3. And the distance from the person to the mirror is 7.2. So that's right here, 7.2. The distance from the person to the base of the building is 1,750. So that means, I'm going to kind of do it in red here, from the person, this, way over here is 1750. And the height of the building will be represented by X. Okay. Oh, I mislabeled this. I'm sorry. This says straight down, and I didn't realize that. So straight down, that means this side is 5.3. All right, so we did that. Well, now we want to figure out how tall the building is, and I actually have enough information, but I do have to do something first. All right, so I'm comparing, right? If we count the first one again as our pre-image, and then this one will be our image. So when I'm setting up my proportion, let me move this up a little bit, I have 7.2, and then I have this distance, but what I have here is I have the entire thing, and I have to subtract my 7.2 out because I only need this part. That's the part that I need. So I'm going to do 1750 minus 7.2. So this part is really 1742.8. So 1742.8. Then I have how tall the person is, 5.3 over how tall the building is. Right? So we kind of, instead of the shadow, we now had the distance, to a point. Same idea. So I'm going to do my cross multiplying. 7.2x. Oh, I'm doing way too much here. This answer should have been for part C. This is what you get. See, don't be like me and not read the question. This is where I need to be doing my solving. Sorry about that. All right, so 7.2x equals 17428 times 5.3 gives me 9236.84. Divide by 7.2. And I'm going to get 1282 point. It says approximate, so I'm going to round it to the nearest foot. So 1283 feet. All right, so a little bit different, but based on the same idea of being able to set up that proportion. So let's see if we can try another one here. So now what we have, all right, a geologist wants to determine the distance across the widest part of a nearby lake. The geologist marked off specific points around the lake so that DE would be parallel to BC. So those two lines are parallel. Okay. The segment DE is selected specifically because it was short enough to measure easily. The geologist sketched the situation as shown. Has the geologist done enough work so far to use similar triangles? Yes, because we now have, if these are parallel to each other, the blue angles are going to be congruent and the red angles are going to be congruent. All right, so yes, there are two pairs of congruent angles. All right. The geologist made the following measurements. I'm going to erase my drawing over here so that I can fill this in nicely. All right, so we basically have two different triangles that we're dealing with. We have ADE is a small one, and then we have ABC is the big one. All right, so let's see what we know. We know DE is 5, so DE is, fill that in because it's red, so that distance is 5. We know AE is 7. A is 7, that's in the small triangle. And EC, so from here to here, is 15. Does she have enough information to complete the task? Well, our task is we want to know how big it is across the lake. Yes, we do have enough information. All right, so again, I'm going to set up my proportions. But the problem, not the problem, the issue is that I know this little piece, the 7, and I know this little piece, the 15. I need this whole side. So this whole side is 22. So now I can set up. So if I do small to big, that's kind of the easiest way to do it here. So I'm going to have 5 over 22. And then I need, that's the wrong number. How about 7 over 22? And then I need 5 over x. Cross multiply, we're going to get 7x equals 22 times 5 is going to give me 110. Divide by 7. And you're going to get x is 15.7 feet, I believe. Okay, let's see. Assume the geologist could only measure a maximum distance of 12 feet. Could she still find the distance across the widest part of the lake? Yes, and we just did it. So I'm not going to make you do that part again. I think we have one more. All right, a tree is planted in the backyard of a house with the hope that one day it will be tall enough to provide shade to cool the house. A sketch of the house, the tree, and the sun is shown below. All right, what information is needed to determine how tall the tree must be provided to be provided the desired shade? Well, I need to know how tall the house is. Right, because in other words, I want the tree to be this tall. I need to know how tall the house is. Right, and I need to know the distance from the point on the ground to the house and to the tree. Or I need to know the distance to the sun. Either way. All right, assume the sun casts a shadow 32 feet long from a point on top of the house to a point in front of the house. So here's your house, here's its shadow, 32. Okay, then we have the distance from the end of the house's shadow to the base of the tree is 53 feet. So that means from here to here is 53. If the house is 16 feet tall, how tall must the tree get to provide shade for the house? Right? These are like our problems from yesterday. So when I'm doing this, right, I can set up, I'm going to do, again, I'm just going to go from 32 to 53. And then I'm going to have, 16 over x. And I'm going to do my cross multiplying. 32x equals 53 times 16 is 848. Divide by 32. Gives me 26.5 feet. All right, so a little bit more complicated, a little bit more reading involved, but that doesn't mean that you can't do it. You have to have some confidence in yourself. So work on it, try it more than once, but any questions, bring them to class, and have a good night.